Hi students, how are you? So in last class we were discussing about the poles of a magnet and we saw that a magnet has two poles. And today we can discuss how we can use a magnet for finding directions. So our next topic is finding directions. So magnets were known to people from ancient times and many properties of magnets were also known to the people in ancient times. And you must have read many interesting stories about the uses of magnet. And one such story is about an emperor in China. So it is said that this emperor had a chariot with a statue of a lady that could rotate in all directions. So there was he was having a chariot and there was a lady at top of the chariot and that statue was able to rotate in all directions. And it had an extended arm. One arm was extended as if it was showing directions. So you can see that picture in your textbook. So this is the picture of the chariot of the emperor. There is a statue of a lady and one arm is extended. And this statue was able to rotate in all directions. The statue had an interesting property, that is, it would rest in such a position that its extended arm always pointed towards south. So we know the one arm was extended and that arm was always pointing towards the south. So when he stopped his chariot somewhere else, he can find out the directions by looking at the arm or extended arm of the statue. Because always the statue was rotating and when the chariot was stopped, statue will stop rotating and it will come to rest and its extended arm was pointing towards the south. So by looking at that arm, he was able to know which is the south. Okay. So by looking at the extended arm of the statue, the emperor was able to locate the directions. And when he went to any new places on his chariot, he don't know the directions or place. So what he do? He look at the extended arm of the statue and find out the directions. And now we can make such a direction finder for ourselves. So now we can do one activity. So we can do activity 5 in your textbook. So for that we should take a bar magnet. So take a bar magnet and tie one thread in the middle of the bar magnet. And to find the two ends are there. So you give one mark in one end. So here there is a white dot in one end. So you put one mark in one end. Then tie a thread and hang it. Okay. So we can see this magnet is rotating, moving. Now we can look in which direction this magnet come to rest. Now we can see that it come to rest in this direction. Okay. So I am talking, that's why it is moving. So it come to rest in this direction. So you look at the white mark, white point is directed towards this side. Okay. Now again I am moving this. I am changing its direction and now we can look again how it come to rest, in which direction. Now also we can see it is coming to rest in this direction and you look here, the white mark is again pointing towards this side. Okay, now we can do the same activity with a plastic pen. So here I tie one thread to a pen and I am rotating this. Now we can look how it comes to rest. Now this pen comes to rest in this direction. So it is pointing towards this side. Now again I am rotating and we can look how it is coming to rest. This time you can see that this pen comes to rest in this direction. That is, it is pointing towards this side. Okay. So here when we took the magnet, we saw that magnet was always coming to rest in same direction. It was not changing its position. Same end was pointed towards the same direction. Okay, so that is one important property of magnet. Magnet always come to rest in the same direction. So from this activity 5, we understand that a magnet always come to rest in same direction, or a freely suspended magnet always come to rest in same direction. Now we can look at the directions. So here we know this is the north and this is the south. So this was coming to rest in this direction. So this is the north and this is the south. So here this magnet is coming to rest in which direction? It is coming to rest in north-south direction. So this is the north and this is the south. So this bar magnet always come to rest in north-south direction. Okay. So if you don't know the direction, we can look at the sun. So here now I know this is the north and this is the south. But if you sometimes we don't know which is north or which is south or east or west, then we can look at the sun and find out the direction. We all know sun rises in the east. So we know. So in the early morning, look at the sun. So in which direction you can see, that is the east. So now you understand which is the east. So if this is the east, what about this direction? This is the east, then surely the opposite side is the west. So by looking at the sun, we know which is the east, and then we know the opposite direction, that is the west also. Okay. Now how you can find out north and south? So if this is the east, this side is east. You stand facing towards east or facing towards sun. Then your left side is your north and right side is your south. Okay. So if you stand facing the east, then left side is the north, right side is the south. But if this is the east, then you can stand like this. Then this will be the north and this is the south, and back you can say that is the west. So by looking at the sun, you can find out the directions. So in olden days, people look at the sun and find out the directions. They look at the sun, rising sun, and find out which is the east. Then opposite side is the west. Then stand facing towards the east. Then the left side will be the north and right side will be the south. So like this, people find out the directions in olden days. So now we understand that a magnet come to rest in north-south direction. So one end is pointing towards the north and the other end is pointing towards the south. And the end of the magnet or the pole of the magnet that point towards the north is called north-seeking end. North-seeking end or north pole. Okay. So here this is the north. So this end is called as north pole of the magnet or north seeking end of the magnet. We know magnet has two ends or two poles. One pole is called as north seeking end or north pole. What about the other end? That is called as south seeking end. South seeking end, or it is called as south pole. So which are the two poles of a magnet? North pole and south pole. And usually this north pole is marked in a magnet. So here you can see a white dot. So white dot that is showing it is the north pole. So usually on north pole there will be a mark on the magnets. So by looking at that we can identify which is the north pole of the magnet. Today we understand one important property of magnet, that is a magnet come to rest in north-south direction. And this property of the magnet is very useful for us. For centuries, travelers have been making use of this property of magnets to find directions. Travelers, they want to find out the directions. So they were using this property of a magnet. So it is said that in olden days, travelers used to find directions by suspending natural magnets with a thread. So they were taking some natural magnets with them. When they suspend it on a thread and find out in which direction it is coming to rest, and they find out the north and south. Okay, and they find out the directions. So they were always carrying a natural magnet with them to find out the directions. Later on, a device was developed based on this property of magnet, and that device is called as compass. So in compass there is a needle, magnet needle, and it always comes to rest in north-south direction. And by looking in the compass, we can find out the directions. So in next class, I will bring a compass and we can discuss about compass. Okay. So today we were discussing about the poles of a magnet, and we saw that a magnet has a north pole and a south pole. And we learned one important property of magnet, that is a freely suspended magnet always comes to rest in north-south direction. Clear now? Okay, bye.